Okay, so you understand the basics of electrical movement, but you understand how it's produced in the first place. If you think about a magnet, here's a simple bar magnet. It has a north side and a south side. So that's easily enough understood. You've seen this picture before probably 1,000 times in your life. And basically, we have these little imaginary lines that help us understand the strengths and locations of magnetic fields. And I can continue drawing these for as long as I want. But if we move this, then these magnetic fields can actually induce a change in the position and also the speed of this change, the rate at which it changes, for charge carriers. Again, in the case of electricity that we care about, this would be electrons. So we can influence the position of electrons and how quickly they change their position based off of the position of a magnetic field and how quickly we change that magnetic field. And you can also change the direction. So for instance, I could have an electron that's influenced in one direction, and then I could continue to influence electrons along that way, maybe making a sloshing pattern, almost like a garden hose, a pulsed garden hose, if you will. Or I could have an electron move backwards and forwards. And these are the very basic methods which with electrical motion is carried out. So both are actually very valid methods, and there's a long historical reason on why sometimes we've chosen to slosh electrons along in one direction, influencing each other as they go down the chain, and then also having electrons just slosh back and forth. So ultimately, the sloshing back and forth, which we call alternating current, which you can see you alternate your position forward and backward, positive and negative. This motion was basically built into everything residential, commercial, and a large-scale electrical use. And then the direct current, which we call that sloshing forward of electrons in one direction, really kind of took the back burner. And if you look historically, they both had excellent little applications. So if we look at the electrical production and aren't too concerned about how the generators are built, we just accept the fact that we can graph out the voltage produced versus time. So I'll make one graph. There's time, some arbitrary units. And this will be voltage. We have those two scenarios. We have one where you slosh back and forth, and you have one where you slosh forwards. Again, these are very basic ideas, and they are a little bit more complex in the foundational reality of it, but I don't really think that really matters at this time. So we look at it, we call one direct current, and direct current in theory is constant, and so you'd actually have a certain energy level that's available, and we would typically consider this positive. And so the energy level is available constantly across time. And so this would be a really ideal battery or some other storage device, electrical storage device, because you wouldn't have degradation over time. This would maybe be a really large battery, and the geometry and the chemistry of the battery wouldn't really cause it to go down. But in reality, what you end up having is gradual degradation, and the really good batteries take much longer to get to this point. because after a certain period of time, your electronic equipment is not going to work. And I say electronic equipment because that's usually what you think about when you talk about batteries, but really any type of large-scale electronics or electrical system depends on a specific voltage range. You have to be above a certain point for you to initiate any motive force. So that would be direct current. We can look at alternating current and say that we start out at a certain position and then the voltage goes from positive to negative, and this is what you really would find in your house in most commercial situations. But I want you to think about something. Even though most of our equipment on the large scale especially is using this alternating current, this back and forth sloshing current, actually a lot of the smaller scale equipment we have to invert. We have to use inverters in line with our transformers to step down from the higher voltage residential or commercial use voltages and actually rectify them so that you go from the alternating current to the direct current. And really, if you think about it, a lot of the electrical production that we use currently is DC current. So think about a very common renewable energy, solar photovoltaic systems. This is direct current. So they are producing something very similar to a battery, at least a current form like that. And then we have to change that through an inverter in order to make it look similar to an alternating current signal. It effectively is alternating current at that point. So I would like you to think about the fact that even though we historically have chosen alternating current, direct current is really making a new stand in history. And so you should expect to see a lot of the lighting options becoming more DC based, more direct current based, as some of them are, and maybe even beyond lighting.